All right, so we have a leaving group and then a nucleophile in an SN2 reaction. We already talked about what makes a good nucleophile, or a good leaving group. Now let's talk about what makes a good nucleophile, or let's talk about the nucleophilicity of a compound. So the nucleophilicity of a compound is how fast a nucleophile will attack an electrophile. And this is very context dependent, but what we're going to basically say is that strong nucleophiles favor SN2 reactions, right? We'll learn some other reactions where strong nucleophiles won't favor them. So what makes a strong nucleophile? The number one thing we want to look at is a negative charge. Right? The more negative it is, the better it is. And that makes sense, right? The more negative it is, the more it's going to want to get into that nucleus, right? So for example, if you have hydroxide reacting here as a nucleophile, this is going to be fast because this is a strong nucleophile. However, on the other hand, instead of hydroxide, if you had just neutral water acting as a nucleophile, this is going to be very slow because water is not a good nucleophile because it doesn't have this charge. And it's also not, never mind. So we'll just say weak nucleophile. Right, in this case, this is too slow to be useful from an SN2 perspective. The second thing we want to think about is basicity. And so if you notice, bases and nucleophiles are very similar to one another. And so basically, the more basic you are, the more nucleophilic. However, this is only true across a row. Right, so when we're talking about like carbon with a negative charge, nitrogen with a negative charge, oxygen with a negative charge, or fluorine with a negative charge, the more basic one, or the carbon, is going to be more nucleophilic.